Well, we've been working on algebra with two unknowns. And algebra and science are so intertwined because you can't really go very far into chemistry or physics without a good understanding of the basics of algebra. And occasionally, at the schools that I've taught at, I've been teased by some of the science teachers saying, "Don't you teach them how to do certain things in algebra?" And I always say, yeah, we do. And there's a topic that's going to come up here, and I think that I used it personally more frequently in chemistry and in physics than I ever did in any of the pure math classes that I have. But let's take a look at it. Here's a case where if you learn enough algebra, it will help you get a very good grade in chemistry. So at least that's been my experience, because it helped me so much to write lab reports. So here it is, right at the top, direct and inverse functions. Now I'm going to bring up the marker here. I've got this little one. I don't know what I was doing. We have, the scientists are sometimes interested in whether things vary directly or inversely. First I used to think it was indirectly, but it's really direct and inverse variation. And we have the formulas here, and I made it so that they show up if you click these option boxes. And I'm going to bring up a marker and talk about this, though I have been told by some students that I make too big of a deal of it, and I'll tell you their shortcut in a minute. When something varies directly, like in chemistry, let's just take the simplest scientific experiment. Putting sugar in your iced tea. The amount of sugar that you can put in your iced tea varies, is proportional to the temperature of the tea. The hotter it is, the more you can put in. Pretty straightforward. If you haven't noticed that, you're not a very good observer. The warm tea, you can dissolve more sugar in it. Cold tea, if you've ever had cold iced tea and then try to put sugar in, you just see the sugar falling to the bottom, because the amount that you can dissolve is proportional to the temperature. We say that these have a direct variation. And in math, we say we can go from the idea that things are proportional, like this thing that looks like a fish. This really says is proportional to. You can change that to an equation if you introduce a constant of proportionality. Now we're dealing with direct variation. Now, this is kind of crazy that they spell constant with a K. Who knew? But they like to use K for this constant of proportionality. So you go from this proportion statement to this constant statement. Now, if we solve this equation for the K, then we would want to get rid of the T and divide like that. So we see that the constant is equal to the amount divided by the temperature. And this would be the constant of proportionality for, say, dissolving that sugar. So if we were going to do experiments and we said, I found out that at a certain temperature, I could get, 4 ounces of sugar at a certain temperature, and I wanted to know how much I could dissolve at a different temperature. So I'm going to have the amount for the first experiment, the temperature for the first experiment. Then I'll have the amount in the second experiment and the temperature in the second experiment. And since this is the constant of proportionality for the way these things are related, this statement becomes true. A1 over T1 equals A2 over T2. This happens in direct variation. Got that? Now, in indirect inverse variation, whatever you have, the amount is proportional not directly to the thing. Was when the one gets bigger, the other doesn't get bigger. It's proportional to the inverse, or the reciprocal of that amount. I'm using these things with temperature and A, but that's not really true. I should probably think of another situation, whereas one thing gets bigger, the other gets smaller. But let's just use the same letters so that we can see. But we could use X and Y as well. So this would mean as the one thing gets bigger, the other one gets smaller. Let's see, like the more pressure you put on a balloon, the smaller the volume, or something like that. So you could go from this proportional statement that's saying that as one thing gets bigger, the other gets smaller, and put in a constant of proportionality, put in an equal sign and put in a constant divided by t, and then solving for the constant, you get A times T equals K. This is no longer temperature and amount anymore. So the constant of proportionality, and so we could say our A in our first experiment times the time in our first experiment is equal to the A in our second experiment times the time in our second experiment. And this is how we can use the constant of proportionality for some experiment that we're working on. In the labs for chemistry or physics, sometimes we're searching for these constant values. Now, I've taught this for many years. One time I was teaching a pre-algebra class that was, and I was explaining all this, and they sort of listened, and they said, all of a sudden this one kid raised his hand. He said, "You're just making that too hard for us to remember." He said, "Ms. Howe," he said, "look at this. You're making us think about all this proportionality and constant proportionality, and we know we're having two experiments. And it's just easier to remember that if you have direct variation, you set the problem up with a division, and you say the x in the first experiment divided by the y in the first experiment is equal to the x in the second experiment divided by the y in the second experiment. And if you have inverse variation, you just say times x in the first experiment times y in the first experiment equals x in the second experiment times y in the second experiment. So who knew? But they were right. This is a way of thinking. If it's a direct variation, you set up your experiments with division, and if it's inverse, multiplication. Let's look at some of these problems, and maybe your science teachers will not be bothering us math teachers about how you don't know about direct and inverse variation. Do us a favor and learn this. That'd be really good. I'm going to minimize the marker out of here, and we're going to look at a problem. Now, this is saying that y is inversely proportional to x. So if we take my student's hint, then that would be saying it's inversely, so we're going to take x in the first experiment times y in the first experiment equals x in the second experiment times y in the second experiment, and the constant of proportionality would be those products. So it's saying if x is 9 when y is 18, find x when y is 27. We want to get x by itself, so that means we have to get rid of the 27. So I'll just divide this side by 27. If I do that, I have to save the world and divide this side by 27. And 3 goes into 27 9 times, and 3 goes into 18 6 times, and 9 kills off 9, and we get x is 6. I'm going to get the marker out of the way and put in that 6, and check, and we're going to win. And see, these are inversely proportional. As the one gets bigger, the other gets smaller. And they actually end up graphing inverse graph on these hyperbola lines, which we haven't studied just yet. but we will. See, the way they're related is along a line like that. Let's try another problem, another inverse problem. I'm going to put the marker up again. And this is the x1 times y1 equals x2 times y2. And I should have said what the constant of proportionality was in that, but I forget what the numbers are. We'll do it on this one. If x is negative 18, when y is 4, find x when y is negative 2. So, looks like our constant here would be whatever, 14 times 18, 4 times 18. 4 8 is 32, negative 72. Oh no, it'd be 72. I think. All right, so we want to find what our x is anyway. So we're going to have to divide both sides by negative 2. Negative 2, kill, kill. And this will divide out 9 times 4. It looks like it's 36. We minimize this. 36. Check, we win. Another parabola, but this one is going the other direction. I'm going to get good. We got a direct variation one. Now remember, my students who helped me to remember what's what said, Ms. Howe, if it's directly proportional, you're setting it up with a division. So x in the first experiment divided by y in the first experiment equals x in the second experiment divided by y in the second experiment. So if x is negative 5, when y is negative 10, find y when x is 4. So we could reduce this side or we could cross multiply. We have a lot of algebraic choices here. I think right away, though, I would multiply both numerator and denominator of this by negative 1 and get this positive. I'd be inclined to make that into 1/2 is equal to 4 over y, and then now I cross multiply. Looks like y is 8. A rather simple answer. Minimize 8, and we win. Now this time, and it says the constant of proportionality is 2. And you can see that these, as the one gets bigger, the other gets bigger. These are on a straight line, which is what we are studying. At this point in Algebra 1, we're actually studying direct variation, but I always like to teach direct variation and inverse variation together because they are so useful in the sciences. So try to practice these and get good at them. Have fun in algebra, chemistry, and physics. Go science. Thanks. Bye.